Hello, welcome to this introductory video on breadboarding. We're going to look at what a breadboard is, how to build a simple circuit using one. We'll also look at a few basic circuit components and how to represent a circuit in a diagram. These little gadgets are called breadboards because in the early days prototype circuits would be built on pieces of wood with nails banged into them and connected with wires and components. The pieces of wood were, well, they were breadboards that bread would be cut on. Now we use these. In order to build a circuit on a breadboard, you need to understand how it's organized. The way it's organized is that there are columns or rows of holes that are connected. So on this breadboard, these 5 holes are connected electrically. If we plug components into this column of holes, then they'll be electrically connected. However, this row of 5 holes is not electrically connected to the 5 holes opposite or the 5 holes adjacent to it. I'll just show you why that is. If I peel away the backing of this little breadboard, we can see that the five holes here are joined, but they're not joined to any of the other rows of holes on the breadboard. To make a circuit, we just need to plug our circuit components into the holes in the breadboard and make sure that we have a connected loop of circuit, a continuous connected loop of circuit around the breadboard. So probably the easiest way to show you that is to actually build one. So let's just start by looking at some of the components that we're going to use. This is a battery pack. It's got 4 AA batteries, each, well, actually technically one of these is called a cell. So this is made up of 4 AA cells. Each cell is 1.5 volts. They're connected in series, which means they're connected end to end, and that gives a total of 6 volts. So here we have a 6 volt direct current energy supply. These are the leads for the battery. So the positive terminal of the battery has this red lead attached, and the negative terminal of the battery has this black lead attached. So we can plug, what we normally do is we start our circuit at the positive end and we plug our positive terminal, sorry, bring that back into shot. We'll plug our positive terminal into a hole anywhere on the breadboard, to be honest, and then we plug our negative terminal anywhere on the breadboard. I can put it down here. We can plug it anywhere. It's not connected at the moment because these holes aren't connected to these holes. If I plug the negative terminal of the the negative lead of the battery into the same row of holes as the positive lead, what do you think would happen? Well, the answer is nothing good. Okay, so what would happen is we would have created a short circuit. In other words, our current would flow in here, and because it would be connected to the, if I put the negative terminal in there, which I'm not going to do because it would be dangerous, the current would flow through here, it would be connected to here, flow back into the battery. So we'd have a circuit for sure, but there'd be no resistance in the circuit, and a current with no resistance quickly gets very large and the battery pack will melt. You might have a fire. So over here they're not connected. Right, so what we need to do now is join this to this with our circuit components. So the next circuit component we're going to use is a resistor. Most of the ones you'll be using will look like this. This resistor The resistors are color coded. You probably can't see the colors on this, but that's a brown band, which corresponds to the digit, the number brown is 1. This is a grey band, which is 8. So, and this is a brown band as well, so which is 1. So this resistor is 1, 8 with 1 0 in the end. So it's a 180 ohm resistor. I'm going to put one leg of the resistor in the same row of holes as my positive lead, so it's now connected, and I'll put the other leg anywhere else in the breadboard. It doesn't matter which way around you put the resistor. Now, all we need to do now is put our light into the circuit. Now, this is an LED. LED stands for light emitting diode. It has a long leg and a short leg. The long leg is the positive side, the short leg is the negative side. The positive side needs to go to the positive side of the circuit. So this is the positive side of the circuit, so the long leg needs to be connected here. So if I put the long leg in here, it's connected to the resistor. And I can put the short leg wherever I like, not in the same row of holes here, of course, because then the charge wouldn't flow through the LED, it would just short circuit across the bottom of it. To complete the circuit, all I need to do now is connect the negative lead to the negative side of the LED. There's two ways I can do that. I can either take a piece of jumper wire and then connect them, but probably the easiest thing is just to remove the negative lead and put it into the same row of holes as the negative lead of the LED. Okay, now I don't know if you can see that, but the light just came on. So we have a completed circuit. The charge, we imagine that they're positive charges flowing, so that the positive charges come out of the, they're not really, but we work that way as electricians. So the positive charges come through the red lead out of the positive terminal of the battery. That's connected to the resistor, so they flow through the resistor. Okay, that's connected to the positive side of the LED. They flow up through the LED, down, and that's connected to the battery and then back into the battery. So we have a completed circuit, hence the light is on. If we break the circuit anywhere, charge stops flowing. It doesn't matter where I break it. I can break it here. The light goes out. Okay. It's important to realize that wherever I break the circuit, it stops the charge. So even if I break the circuit after the light will still go out. We need a continuous loop of conducting material for the charge to flow in a circuit. So I'll put that back in. All right, the light comes back on. It's also important to realize that with the LED, the long leg needs to go towards the positive side of the circuit. They're unidirectional. If I put the LED in around the other way, it won't work. It won't do any harm, but it won't work. You can see that the light doesn't come on. So I'll put it back around the right way. Oop. This is good for your fine motor skills. Okay, so there we have a completed circuit. So what we're going to do now is we're going to look at how we can represent that circuit in a diagram. Circuit diagrams are very useful because if we have a very complicated circuit made up on a breadboard, then it can be quite confusing what's going on, and a circuit diagram can simplify it significantly. So in order to make our circuit diagram, we need to know a few of the circuit component symbols to put into the diagram. So this is the symbol for a single cell, or one 1.5 volt AA battery, for example. This is the symbol for a battery of cells, which is what we were using. Another way we can represent our battery is with a symbol like this, which is a direct current power supply, which is what our 6 volt supply was. The other symbols that we need to use are this, which is a piece of wire or connecting lead. We also need to use this, which is the symbol for our resistor, and we would label it with the value here. And we need this, which is the symbol for our light emitting diode. So I'll bring the circuit back in, put it there, and let's draw our circuit. So we can start with our battery. So I'll use this symbol. So from the positive side of the battery, we take a piece of wire. The first thing we come to is our resistor. So we draw that in. The next thing we come to is our LED. So we draw that in. And then from the LED, it's connected back to the negative side of the battery. So this circuit diagram represents the circuit that we have made. Now we would normally label the values. So this is a 6 volt battery. This is a 180 ohm resistor. This is the symbol omega, which is the unit symbol for resistance, which is ohms. And here we have our LED, which we don't really need to label. And we imagine that the current is flowing around the circuit in this direction. What's important with circuit diagrams is the sequence of the components, not how it's arranged on the paper. I could just as easily have drawn the circuit like this. I could have put the battery like that. I could have had the charge flowing out of the positive side of the battery through my resistor, then through my LED, and then back into the negative side of the battery. Again, labeling my battery as 6 volts and my resistor as 180 ohms. Both of these circuits are identical because the charge flows from the positive side, firstly through the resistor, then through the LED and back into the negative side. Now the order of components actually doesn't affect how this particular circuit operates, but it's good practice to draw the circuit diagram to represent the exact circuit we've made with the components in the right order. So that's the end of this video, and hopefully now you have a bit of an idea about what breadboards are and how to make a simple circuit on them. You also have been introduced to some of our basic circuit components, which is our battery pack, the leads, positive lead, negative lead, a resistor, which controls the current, and a light emitting diode, which provides light. It converts the energy from the battery into light. And we've also looked at how to represent a circuit in a circuit diagram. So thanks for watching.